Let's take a look at a demo of XML external entities. In particular, I want to point you to this prevention cheat sheet that's really good from OWASP. I've mentioned it in the course a couple times about cheat sheets that are pointed at by the various threats and risks that are listed as a really good extension of the OWASP Top 10 so that you can put into practice, you can understand better, as well as see some actual code examples of the particular issue that they're covering. This cheat sheet in particular has been updated quite a bit actually in the last 6 months or so since the OWASP Top 10 2017 came out. And in particular, it has some code examples, for example, C, C++, Java, .NET, iOS, PHP, and so on. In particular today, what I'm going to be looking at is the .NET aspects of it. If I scroll over to that location within the site, it mentions a couple of things here. First of all, I'd like to point out that ever since .NET 4.5.2 and beyond, many of the XML libraries that are available in .NET by default already have the protection in place for DTT processing. I mean, that's essentially what we're talking about here, is making it so that certain entities would not be executed through a DTT processing. And just as a quick reminder, if you have an XXE vulnerability present, what you're seeing essentially is the possibility of an attacker being able to read files. If they know there's a file, let's say for example a password file on your network, on your web server, and they're able to access it, they could potentially cause a denial of service. They could also potentially cause or open a remote code execution pathway into your server and be able to execute certain commands and so forth using simply XML and getting the XML parser to be able to execute that command. So as I mentioned, this particular graph here shows you what is present by default now in .NET 4.5.2 and beyond, rather, or 4.5.2 beyond. But prior to 4.5.2, some of these were not. In other words, by default, they would process DTD. They would process and execute potential XML entities or external entities. So let's take a look at some examples here. And in order to do that, I want to look at some really good code that's available on GitHub by Dean Fleming. And so this link takes you to GitHub. And when you go there, you'll notice there are some really good examples. For example, you can set up your environment for .NET 4.6, .NET 4.52, .NET 4.51, for example. And what you'll find is as you read about this, it will indicate that in order to run the test programmatically, you want to make sure you have the Chrome driver installed, where you can go to sites.google.com. You can download that, and what that looks like here is various versions, Linux, Mac, and if you're using Windows like I am, you would download the Windows version. But let's take a look at the actual code, and I have it running here at the moment. This is a solution, .NET unit tests, and in particular he's covering various test cases, and the one we're most interested in at the moment is the XXE version. And the way it's set up, let me take a look at the website itself, is that when you run this, you have the .NET XXE injection test. That's where I start with here. And what we have here is testing various parsers. So XML link, XML dictionary reader, XML document, XML node reader, XML reader, XML text reader, XPath navigator, XSL compiled transform. I'm not going to cover all of these today, but I want to give you at least an understanding of what's going on here. So first of all, let's take a look at link. In all the tests, he's sending in this XML, potentially vulnerable XML, or rather a compromised XML, in order to use it to compromise the system. What we're trying to do here is simply saying to the system, retrieve back a file name called XXE attack.txt. And again, it could be password, it could be all kinds of things that you could try to get, files that you want to read back. And by saying, display that text here, let us know if it works or not. Now, when I submit this, in this case, it's safe, no file was returned. If we look at the code again, just to get an idea of how this all works, here's the XML file that we saw that gets sent in. And here's the attack text file that we're trying to retrieve. And all it really is just injection successful. And the reason those couple of words are in the file is that every test that's run is simply looking to see if successful was pulled into the XML, resulting XML. In other words, did that file get pulled in and as a result of being executed, and so therefore we can find out if it's there or not. If it wasn't, then we know that everything was good. And so the tests that we ran turned out that everything was fine. But let's look at one that doesn't work correctly. So if we go back here to the test again, and let's run an unsafe one. In this case, we're going to run something that's unsafe, and sure enough, we do get injection successful as part of the resulting XML output. Looking at the code for that particular test, look at the link code. What you'll notice here is that what makes this unsafe is that we're forcing a DTD processing to happen. So by default, this is not set, but as you can see, it is going to get set here when we run this particular method and this particular, sending the data in. It gets set to parse, and therefore it fails. All right, let's take a look at another example.